We're doing this study principally because of concerns in the upper Mississippi River. And that's because the upper Mississippi River is still relatively free from Asian carp, and because they have the greatest capability to prevent Asian carp from invading, because they can regulate flow through the locks and dams. But these studies have broader geographic applicability. The reason is there are small side channels and oxbow lakes that are also connected to the Mississippi River throughout its length, including right here in the lower Mississippi Basin. And in those cases, when waters flood and Asian carp invade, if you wait long enough, they die out. Most Asian carp do not live very long. But the problem is if those water bodies are periodically connected, either through water control structures or through lake regulation. And there you have a lot of potential for the fish to invade side channels or oxbows. And by knowing what the swimming capabilities are and by regulating the flow through those types of channels, we can prevent local infestations, even in areas where you have large populations of Asian carp. The other application is to the east of us in the Ohio River. Asian carp have been working their way up into the Ohio River, and there are concerns that they could invade the Great Lakes through Lake Erie by connections that occur in the headwaters of the Ohio River that connect periodically with Lake Erie. And by being aware of just how quickly these fish can swim and through what speeds of water, we can develop velocity barriers in those areas too. Hydraulic barriers, while potentially very effective, are not a panacea for Asian carp control or management. They are probably the principal tool for the upper Mississippi River, but they also have very broad applications throughout the country. Bottom line is that they are a relatively inexpensive and potentially very effective tool in integrated Asian carp management.
Preventing the spread of Asian carp continues to be a challenge to the Corps of Engineers, especially since these species continue to spread throughout the Mississippi River Basin into the lower Missouri River and Ohio River basins, as well as into coastal rivers along the Gulf Coast. The Aquatic Nuisance Species Research Program is the Corps' primary R&D program to address aquatic invasive species. This is a national program that is managed at ERDIC Environmental Lab in Vicksburg, Mississippi. It addresses many different aquatic invasive species, including harmful algae, invasive fishes, sea lamprey, and suckermouth catfish, and invasive mussel species such as zebra and quagga mussels that are impacting the western states right now. The goals of the program are to, first and foremost, provide guidance, science-based guidance to field personnel on the most effective and efficient ways to manage, prevent, and monitor invasive species that impact Corps projects, to reduce the impacts and O&M expenditures on Corps operations and infrastructure, and finally, and equally important, to restore native habitats and communities. The application and use of multiple strategies, such as hydraulic and acoustic and electric barriers, as well as harvesting, will provide a robust integrated strategy for management of invasive Asian carp species.
So in WRDA of 2014, Congress did allow some funding to go to the upper Mississippi River Basin and the Ohio River Basin. Currently, those are the only two subbasins that are receiving federal funding for Asian carp management other than the Great Lakes. At this time, we do have groups like MICRA, which is the Mississippi Interstate Cooperative Resources Association, which is a group that represents all of the 28 states that encompass the Mississippi River Basin. And that group is really trying to educate our leaders in Washington, D.C. on the fact that we need to think about management of this species from a basin-wide perspective rather than focusing on 2 individual subbasins or just a handful of them, that we really need to take a systematic approach. So the other subbasins, the lower Mississippi River Basin, the Arkansas Red Subbasin, and the Missouri Basin, are all in the process of developing Asian carp management frameworks and trying to put together some planning documents so we can try to get a handle on what are the activities that we would do to help manage, to help control and prevent these where possible. And so the idea being that when we do have available funding in these other subbasins, then we're ready to take action. We're ready to move, and the states are on board. They've been an integral part of this planning process, and we can then move forward once we do have some funding available.
The ramifications of Asian carp invasions in waters where they have not already established themselves are huge. And the water body that we're adjacent to right now is a very good example. Forest Home Chute is a side channel off the lower Mississippi River and was famous for its recreational fishing. It maintained a very large and diverse fish community. And now it is dominated in biomass by silver carp. It's overwhelmingly the most abundant species in this water body. So essentially we have negated any kind of recreational value that this water body had. It has marginal commercial value because there are still some buffalo suckers and some commercial species here, but in very low numbers. It would never sustain a fishery for very long, a commercial fishery. And the fact is we have an aquatic system here that no longer functions normally because there's virtually no zooplankton in this water body. We've worked with limnologists and plankton biologists from the University of Mississippi. They were sampling here for 2 years. And other than some very small rotifers, there's no crustacean zooplankton to speak of, and that's really what feeds your fish community. So there's all kinds of effects from these Asian carp. There are the social impacts of reduced recreational fishing. There's economic impacts of reduced commercial fishing. There's a public safety factor because the silver carp jump and can impact boats and the people who drive them. And then there are ecological impacts, of course, because of the reduction in zooplankton and the changes in the phytoplankton community that essentially change the fauna that can live in this water.